Yes, I was given, I mean, we were given 5 minutes each, and I thought I will make it really small and simple. So, yeah, that's why I have much less than the other people. And the topic will be smart pointer parameters. So, it is based fully on the blog post by Herb Sutter. He has Guru of the Week series, and this is an item 91. So here is basically the outline of the talk. The agony of the choice is my attempt at translating the Qual der Wahl from German. And so if you have a function which is going to accept, let's say, some kind of a pointer which points to a widget type, you have these choices, 6, and then const isn't even included, and then you're asking yourself which one should I use, and this is a small guideline for you. So basically, okay, new things are nice and cool, but still the preferred default way is to use a raw pointer and a reference. Why? Because normally we know that the function, the object, the widget that will be used in the function is going to outlive the function. That's why it's safe to use, to pass it like this. And we don't, maybe we don't want to commit to some lifetime management policy. Maybe we would like our function to be used by old code, stuff like this. So we don't want to go straight ahead to some new things if they are not needed. So if you want, so now when to use the raw pointer, when to use the reference. So if you would like to express the nullability, so if the widget can be null, then you use a raw pointer, and if you know that the object won't be null, then you use a reference. And if you know that the object isn't going to change at all, so we use it only read-only, then go with const pointer or const reference. All right, so when we would like to use something like a unique pointer, so this function should basically mean that this function is a sink. So something like a black hole where things just disappear and cannot be used afterwards after the function is called. By using this code, if you know the other members of your team know this, you have a nice idiomatic piece of code, which also means that this is sync, because otherwise you would need to write it in the commands or in the documentation and hope your team members will read it, right? So by using this, you not only implicitly saying in the code this is a thing, but you also are protected by the compiler. If you're going to use this pointer after the function is called, you will get the compiler error, so which is very nice. All right, when to use a shared pointer? The shared pointer we would like to use if this function f shares the ownership of the object. Here we have the case with passing the shared pointer by copy and by reference, by value, sorry, and by reference. So by value we would like to pass it when the function when we really know that the function is going to share the ownership, and by reference we pass it if the function might share an ownership, and also in the case if you use it for in and out parameters. So suppose void f is a function which will set the widget into the pointer. Let's say it's going to decorate a button, right? Accept the button widget, and then I don't know, add some decoration to it and return a new widget back. This is, for example, could be the case. And then there is some homework also here. You probably noticed this case I omitted. I invite you to go to the link which is supplied in the presentation, and read it for yourself. And there is also much more interesting stuff there. So what could at first glance seem so simple is basically not that simple. All right, I'm done.